Hi, Lovelace. It's your celebrity mathematician, the Prof. Amale Jeffrey Jojo. And you can see some of the things we're supposed to simplify here and the assignments. I've been actually waiting for this sort. We're done with other good topics of technological value. And modern technology would be unthinkable without mathematics and its branches like statistics, computer science, and what have you. Now, what we want to look at is what we call sword. Sword. Now, what is sword? I know you say that sword is one thing that has roots, this and that. Now, you may be correct if you have the correct root, but if you have a rational number from the root, it is no longer sword. So let's see. Let's define some terms to give us the understanding about sword. I don't know if you have heard what is rational numbers. This one of the term. Another term that will help us here is what we call irrational number. Irrational number. And another beautiful thing there is also integers. Yes, I've talked about this before. Integers. To drive home the definition of sword before we start teaching what it means proper. Now, rational number is a number that can be expressed in fraction or ratio in form of m over n, and n must not be equal to what? 0, because when n is equal to 0, it becomes indeterminate. If you press your calculator 2 over 0, it will give you mass error. So m over n, if you see a number, real numbers, integers, which if you put in fraction, it can be expressed, that is what? Rational number. Then when we talk of irrational number, these are numbers that cannot be expressed in the form of this m over n, or fraction or ratio. Now, if we said these integers which can be expressed like this, then what is integer? These are positive, negative, and 0. For example, if you have it like this, you can say this is 0. The right hand side, you can say this is 1, 2. To the left, you can say minus 1, minus 2. Then you can put 3 like this, up to negative infinity, positive infinity. Good. Now, these are integers. The whole positive numbers, the whole negative numbers, including 0, are what we call integers. So if we said in form of m over n, which can be expressed, then any number you pick from here, including the negative one, m over n, you can pick 2 over 3. These are integers, including 0. I've talked about it before. So now, what are the examples of rational numbers? It's okay, can be 2, 3. These are rational numbers. Then the examples of irrational numbers. Irrational numbers, for example, we have pi. This example of irrational number, root 2. This cannot be expressed in fraction. Root 3. It cannot be expressed in fraction. So these are what? Irrational numbers. Then we say that if irrational numbers which cannot be expressed in fraction are in form of this root, we now said they are what? Surd. Now let me define surd in a simple sentence. Surd are roots of what? Rational numbers that cannot be expressed in form of fraction. For example, root 2 is a surd. You cannot express further, and when you bring root 2 out, it cannot give you fraction. So these are what? Surd. Good. Now, surd is very important. Surd is what? Very, very what? Important. So we have rational numbers, and when we have irrational numbers in form of root, we say they are what? Surd. Good. Now, we have done that. There are some certain things that can aid us in this surd. It has rules. It has rules. Now let's check the rules. Since we have known what surd is all about, let's check the rules. What are the rules? Number one, there's what we call addition. If you have let me put it in this way for you to get it well. Let me say root 1, you have m root a plus m root b. This will be what? This will give me, let's say this is n, because it can be another number. To give me m plus n root what? Sorry. All of them inside. Before you can add surd, the inside must be the same. Root a. Number 2, I have m root a minus n root a. It will give me m minus n root what? A. Now, what this tells us is that in addition of surd, the surd must have the same value before you can add them. Likewise to what? Subtraction. They must have the same value before you can do the needful. Now, we have number 3. If I have root AB, this is the same thing as root A dot root B. This dot is for me not to be writing multiplication. Is multiplication. Now, why did I write the 2? In multiplication, the surd, if they're in this form, you can separate them. Yes, and if you are taking this one to this place, it's still the same thing. Now, number 4, if I have 1 over root am, this will give me a minus m. Five, if I have a over b, this is the same thing as a over b. This division. If I have something like this, I can easily put it as a over b. It's very simple. It's almost the same thing with especially this, but okay. Number 6, this one, if I have something like this, root a, this is another one, because this one is a revised, to give me 1 over this. This is a reverse of this. But in case you come across something like this, you can express it in this way. So if there are other ones as we are going on, like if you have A, let me put something for you like this. You can say 7. You are the one, as you're solving, you'll be seeing them. They are very simple. If I have A root B dot C root D, as the case may be, this is the same thing as AC B D. Can be like this. For this multiplication, you first take the first outside, they can multiply each other, then the inside also with the same sort can multiply. So having said this, there are other ones that may be generated from all these ones. As you go further, you will see them. So let's say from here we'll play with this, but even from here we can still play with some things and make M under 1. But now let me tell you something here. This, if I have root A plus root B, is not the same thing as root A plus B. Please, in case you say there's plus here, they must have the same inside. And if they have the same value inside, then it will be 2 of it. So I'm not going into that line, but I just want to let you know so that you can go into what to have to do. But I just want you to get knowledge of what we'll use in this sword. And I've told you that sword are what? Irrational numbers in form of roots, which I say root 2 is a sword, Euler's function A is a sword, pi is a sword. So now what do we do here? They give us something to simplify. Root 162 plus root 20 minus root 2. Now what do? The first thing to do is to write what? Solution. We can test this question and they will be the same, these rules. But now let us see what we have here. They say we should simplify. The first thing to do is to write what? Solution. Good. Now A, we have root 162 plus root 20 minus root 32. We have this. So what do we do? Or I can leave this one for you. Okay, so 162, what do we multiply to give us 162? This is an interactive class. So, and we have the second one. So if you want to bring this out, what do? You have written solution and you want to bring it out. You check the second one. So now if you put this in this form, if you cannot solve it, you check the second one. Cannot solve it, you check the third one. If you cannot do any of those things, you leave them in that way. But now let us see. I believe that 162 will be, if I have 81 times 2, 81 times 2, this 2, 2 times 8 is 16. So I have 162. Now, if you are looking at it in this way, it may be very cumbersome. Whenever you have anything and they tell you to simplify in this way, you just look at the numbers inside. What you can do, you check the numbers very well. That's why I was asking for us to know. Now, I have this one will now be wrote 81 times 2 plus this is 20. If I have 20, what I'll do here, I know too well that 20, if I have 5 into 4, I have 20. So I can decide to say it is, or let me take it from the simpler one. I can say it is, let me say 4 times 5. 4 times 5 will give me 20. I can say 2 times 10. Then do that one, I'll say 2 times 5, which will still give me the same thing. But I don't want to go through that line. So this very one is 32. And 32, if I have 16 times 2, I should be able to have 32. 16 times 2, 2 times 6 is 12, 2, 1, 2 times 1 is 2, plus 1 is 32. So I'll break it down like this, that this one is what? 16 times 2. Good. Now, if you look at this one very well, we all know that 9 times 9 is 81. So you come in this way. Remember, I told us something, that we can separate, since it's multiplication, we can separate them. I want to do something here. Since I know that 9 times 9 is 81, I can just bring it out. But let me take it inside. So this will now be what? 9. This will now be what? Let me just put it. The one you know, you bring it out. 81 dot 2. I told you that the dot is multiplication. But since I started with multiplication, let me put it in between. Do you know why I brought this 81 out? Do you know why I brought this 81 out? Because I know that 81 is very simple. Root 81 is 9. So I brought it out. If you find that anyone that you can easily bring out and find the square root, bring it out. Your work will be very neat. So this one will now be plus. This one too is root 4 times root 5. Right? Then this one will be minus. Let me put it so I can show very well, because the place is getting slimmer. So I can see it very well. Let me start from here. This root 81 multiplied by root 2, then plus root 4 multiplied by root 5 minus root 16 multiplied by root 2. Yes. You know why I brought them out? Remember, from this place, so that the two, if two things are multiplied each other in form of root, they can be in this way. So this one is in form of this, so we brought it like this. And why I did it is that I found out that 81, I can find the square root of 81. I can find the square root of 4. I can find the square root of 16. So I have to bring them out. The square root of 81 is 9. So I have 9 multiplied by root 2, right? Plus the square root of 4 is 2. I have 2 multiplied by root 5. The square root of 16 is 4. I have 4 multiplied by root 2. Now, in multiplication, since there's multiplication between them, I can remove this multiplication. So I now have 9 root 2 plus 2 root 5 minus 4 root 2. Good. Now, if you look at it in this way, this root 5 is different. Remember, see the law. The law states that they must have the same thing before we add them. But in this case, this 5 is the odd one out. It's an intruder. It doesn't belong to this place. So we cannot put the 5. So we have to collect the like terms. Collect the like terms. Just write for your marker to know. Collect the like terms. Do you know why I wrote this? So that you know I want to bring this to this place. So now I have 9 root 2 minus 4 root 2 plus 2 root 5. Do you understand? So if I have something like this from the law here, this minus negative law from the law here, I can bring this together. 9 minus 4, right? I can bring this together, root 2. Remember, root 2 can multiply this. I have this. If I want to bring it out, just put this place so that you can know it easily. Root 2 multiplied by 9 will give me 9 root 2. Root 2 multiplied by minus 4 will give me minus 4 root 2. Then this is the same root 5. So this, I'll now put what? Plus 2 root 5. Because root 5 is not the same thing as root 2. 9 minus 4 is 5. So I now have 5 root 2 plus 2 root 5. So at this juncture, since this one does not have the same value with this, you have finished what? Your simplification. So you can now say quod errand demonstrandum. Simply means you have done justice to this. Good. So this is what I did from here. And I believe that I've done justice to them. So these are the few rules or laws I can bring out. As we progress, we begin to see them, other ones. Then I came to this, which is number 1, done justice to it, to get to this. Then let me check number 2. Of course, it's very simple because you know already what we did here. They are having the same root. So this will just be moi moi. But let me just do it as I've written it out. These are the rules. So B, we're given 10 root 2 minus 5 root 2. So what do we do? What do we do? Yes, you have gotten it. Clap on for yourself. Clap on for yourself. I know you are not talking, but I know that you watching this, you have known the answer. So thank you so much. Then can you tell me what you did to arrive at the answer? Yes, I know. I got you. I got you. So this is what you did. So that is 10 minus 5 root what? 2. Yes. Root 2 multiplied by 10 will give me 10 root 2. Root 2 multiplied by minus 5 will give me minus 5 root what? 2. So this is what? 10 minus 5 is 5. So I now have 5 root 2. And you are done with what? The simplification. So it's as simple as what? ABC. So we're now going, what we just did so far is addition and subtraction of surd. So this is addition. We have subtraction was part of it. Fine. And this is the subtraction proper. And we use the rules. The rules state that they must have the same surd before you can what? Add. and they must have the same before you can what? Subtract. Now let's look at the multiplication of sod. That is C. The C. Now we're given 4 root 3, or what? Squared. Now this simply means that 4, or let me bring it down here for you to see. It simply means 4 root 3 multiplied by what? 4 root 3. Yes, because they say squared. Just like when you give me a squared is equal to a times a. So since there's nothing in between them, it's multiplication. Right? That is that about that. Now, this thing simply means, remember, we said that in one of the rules, we said that if we have anything outside, we first multiply the outside. So and I have 4 here, I have 4 here. So I first bring them 4 times 4, then the root. Right? I have the root. So this will now give me times root 3 times root what? 3. Yes. I know when two surds are multiplying each other, like root A dot root A, the answer is what? A. So I think take note of this. We did it. You take note of this. Root A multiplied by root A is what? A. This and that. I told you as we are progressing, other ones will be what? Coming out. So no need of me to put these two into the root, because normally root 3 times root 3 is the same thing as what? The first surd 3 times 3 in the same surd. But since we know, and I have to be telling you so that you can be used to it, if you're having two surds multiplying each other, it is the same thing as what? The same thing as what? Putting one of them, which is 4 times 4 is 16. I have 16 multiplied by 3. Yes. Because root 3 multiplied by root 3 is 3. It's just like when I have the same thing inside, and I say 3 times 3 according to the rule, which will give me 3 times 3 is 9, and square root of 9 is what? 3. So don't need of you to put them inside. Root 3 times root 3 is what? 3. Root 5 times root 5 is 5. Root 10 times root 10 is 10. So 16 times 3 is 16. You put 3. 3 times 6 is 24. 3 times 6 is 6 plus 6 is 12. 12 plus 6 is 18. 8, you carry 1. 3 times 1 is 3 plus 1 is 4. So you have 48. So 16 times 3 is equal to what? 48. So at this juncture, you have done justice to this. I know some of you will be shouting when I say this is that, hey, this. So you must bring it out to be sure that you are doing it well. You don't tell Prof your answer because he's looking at it. And remember, it's video. Some people are seeing us, and I'm a shy Prof. Okay? So now we have done justice to this. They gave us in square. This is multiplication. They want to test us whether we understand the rules. And the rule states that if you have multiplication, first they'll multiply each other, then the root multiplying the root, the same root will give you one of them. So root 3 times root 3 is 3. Root 10 times root 10 is 10. Root 9 times root 9 is 9. So it's as simple as ABC. Then 4 times 4 is 16. Good. Now, another one there that was supposed to do justice to is the number D. The number D. And this number D, I'll use the whole of this board to make it very, okay. The number D. Now look at it here. I hope you are done with this and you are done with this, right? Good. So now, since it's number D, and we have to start, I want to be I want to use the whole of this because this has to do with rationalization, conjugates of sort. I personally brought them out so that I can use them to explain. In this place, we are going to check, after we are done with this, we'll now check the conjugate and know what to arrive at. Sort is a very good and interesting topic. It helps us in modern technology. Helps us in modern technology. Right? Now you know that. Good. Now, we have cleared the board for this. And sorry, let me write the sort out again because that is a very interesting question. Remember, we're still dealing with sort. I took it from here to put it at the center because this D is a very beautiful young lady. It's personification. Don't go and sue me. Feminist. So I now have D. Let's see what the D will give to us so that we can, use the bird. We're given 2 over 3 root 5 minus 4 all squared. Good. Now, remember, why we put all squared is that this thing can be 2. Yes, it's 2. Now, look at it here. What do? We have to bring this out. We'll solve this first. Which is now what? I have 2. Remember, just draw this first. 3 root 5 minus 4. 3 root 5 minus 4. This is what the squared means. 2. Then you put your 2 here in the center. Now, having expressed it in this form, I want to do something that will not confuse you, so that if you want to do it, you can understand it easily. Now look at what I want to do. I first draw my line. Any line is going to, I'll put 2 at the center because it's the numerator. Now I have 3 root 5. I'll bring the whole of this. 3 root 5 minus 4. I'll bring minus 4. I'll bring the whole of this because this is multiplying the whole of this. Minus 4, 3 root 5 minus 4. Do you understand? Have I done anything that is too big? No. This is a square. Square simply means there are 2. Just like a squared, which is a times a. So this is squared 3 root 5 minus 4, which is supposed to be, and it's what I did, 3 root 5 minus 4 multiplied by 3 root 5 minus 4. That is what you are seeing here. Then another thing I did, if 2 things are multiplying each other like that, for you not to be confused, what you do, you take the first one, multiply the whole of the one at the front, take the second one with the sign, multiply with the one at the front, which I took 3 root 5, multiply with this, the same at the front as I explained, then minus 4, multiply with it. Now, we bring it out like this for it to be out. Now, look at what I'm going to do. This, the same thing as what? You draw your line as usual. You can extend it here. I know you understand it. You can extend it here so that it can contain, because we're going to multiply them out. Draw your line. 3 root 5, 3 root 5, 3 root 5, dot 3 root 5. This multiply with this. I don't want to show times, so I put dot. Dot means multiplication. 3 root 5 minus, I now have what? This multiplying with this. I now have 3 root 5. Sorry, 3 root 5. So I have this. This sign is minus here. I have 3 root 5 dot 4 minus again 4 dot 3 root 5 minus 4 dot minus 4. 2. Yes, 3 root 5, if it's multiplying this, since this is the one carrying minus, it has to come in so that you can balance it. I can as well make the minus to be at 4 here. It will still be the same thing. Because at the end of the day, the minus will affect all of them. Then I say minus 4, 3 root 5, multiply 3 root 5, then minus 4 dot minus 4. That is minus 4 times minus 4, the end one. Now, if I do it in this way, you understand with me, I'll draw my line again as usual. So, now look at it. 3 root 5 dot 3 root 5 is, we said in the multiplication law, we said that you must what? Bring the first number out. 3 times 3. Then this one is root 5 times root 5, which is 1 of the 5. So I now have 3 times 3 is 9 dot 5, right? 9 dot 5. Then minus 3 root 5 dot 4 minus 3 root 5 dot 4, which is what? 3 dot 4. If you bring the first one out, dot 4, then you replace your root 5. Because this one does not have the second one. Remember, I told you that root 5 times root 5 is what? 5. Root 10 times root 10 is 10. Then you bring the number out, the number 3 times 3, 9. Because this one is having 3. This one here is having 3. This one here is having 3. And where do we get it from? See it here, 3 root 5 dot 3 root 5. So 3 times 3 is 9. Root 5 times root 5 is 5. Good. Now this one here is 3 root 5. This one multiply this. So you have to multiply 3 times 4. That is 3 dot 4. Then root 5. Because this one does not have root 5. Minus 4. This one now give me, this one is already together. That is minus 4 dot 3. The same root 5. Good. Then this one is what? Minus 4 dot minus 4. And minus times minus is what? Plus. So you have what? Plus 16. I know that some of you are just saying, I know it. But don't talk close to my video so that your voice will not enter. Good. So you now have 9 times 5 is what? I know that some of you will be guessing it. 9 times 4 is 36, if I'm not mistaken. So times 5, add under 9, it will be what? 45. Because 9 plus 9 is 18. 18 plus 18 is 36. 36 plus 9 is 45. Because 6 plus 9 is 15. You add it to it is 45. So you don't need to be using calculator, okay? But calculator is good. I'm not saying that it's bad. So what we have here is what? You draw your line again. 9 times 5, we say that is 45. Good. 3 times 4 is 12. So minus 12 4 times 3 is the same 12 root 5. Good. Minus another 12 root 5 plus what? 16. And is all over what? Is the numerator remains the numerator. Now look at it, what we have done so far here. What we did is very clear. So I can say that this thing is the same thing as what? You know, if I have minus 2 minus 2, it will give me minus 4. You are aware of that, right? So if I have minus 12 root 5, minus 12 root 5 is for me to what? Put them together. 12 plus 12 is what? We have 24. That is 12. 12. This is 4. 2 plus 2 is 4. 1 plus 1 is what? 2. We have 24. So since minus 2 is minus 4, that means you are owing 2 naira and you still borrowed 2 naira. So what you are owing total will now be what? 4 naira. Now this one you are owing 12 root 5. You went to borrow another 12 root 5. So if you add your total debt, it will be 24 root 5. So that is what we have. So it will now be what? 2 over 45 minus 24 root 5 plus what? 16. Now, we are not done here. I want to go through it so that I can clean this one and start from here. We stopped at 2 over 45 minus 24 root 5 plus 16. But I can still do at the front here so that you get it right. 2 over, now since this one is 45, it doesn't contain root. This one is 16, it doesn't contain root. You add them together. It will now be what? 45, 16. And we all know that 6 plus 5 is 11. 1 carry 1. 4 plus 1 is 5. Plus the one I carry, it will be 61. Good. So what I now have here is 61. That is 16 plus 45. Then minus 24 root 5. Yes. This is what we'll be carrying from here before we wipe the board. You all know what I did there? I told you that this one contains root 5, so I cannot add them or subtract. 45 and 16, they are positive. So I have to bring them together. That is 45 plus 16 gives me 61. Then minus 24 root 5 is there. And the 2, which has been the numerator, is still there. So that is what we got from there. So I have to clean and continue from here. So now that you are having like this, you are not done with the sword, because we don't want any root to be at the denominator. So you have to what? Complete it. Remember what to have there? That is 2. Let me bring it out. So we have, what we have there is 2 over 61 minus 24 root 5. That is what we have there. Now, since we have something like this, remember, for us, we are solving this. Hope you are aware. So, we are solving the D. Now, and we come across this. Simplify. You can stop at that level that you simplified, but since we are having this, it's like telling you to do this. Evaluate and rationalize. So I am going to rationalize this. Right? And if I want to rationalize, the same thing that we happened to the denominator will happen to the numerator. Now look at it. That means I have to come to this level again. That is 2 over, sorry, this marker is it's not okay. Good. So if I want to do in that form, I'll have something like this. 2 over 61 minus 24 root 5 . Yes. Then open the bracket. 61 plus 24 root 5. Right? You can bring your 2 to this enter here. Then the same thing will happen to the numerator, which is what? 61 plus 24 root 5. Yeah, somebody will ask, how come about plus? This one is minus. And you just came from nowhere and add plus. You brought the same thing, but you now put plus. That is what we call rationalization. This is the conjugate of the surd. And for you to remove the root sign from the denominator, you have to rationalize. So I have rationalized. And it's from there that I got this. So look at it. What we'll do is still the same thing that we did in other place. So this will give me what? You first draw your line. I don't know where this line will end because this one is long. You have to bring what? 61. Open your bracket. Your own bracket, not my own. Plus 24 root 5. Right? Then bring minus 24 root 5. Open your bracket again. Put 61 plus 24 root 5. Close your brackets. Then bring this person here to 61 plus 24 root 5. Yes, this can be Maths Olympiad. This can be Maths Olympiad question. Because WAEC will just give you from here. They'll tell you evaluate and rationalize from here and leave your answer in the form of A, B, and C. But this one we have to suffer from here, not suffering. We have to enjoy ourselves and break it down from here. So now see what we have. It's from here, 61. I brought 61 out. The one at the front, just as we did in that place. I brought it here. Then minus 24 root 5. The one at the front, I brought it here. So I now say equal to. Now this one here is remaining in that way, but I can work it at the same time. But my major consideration is here. If I finish with here, this one will be very simple for me to do. Now, I now have what? I have to draw my line again because this one will be long, the way I'm saying it. From the numerator, I can start working on it. I have 61 multiplied by 2. This will give me 2. 2 times 6 is 12. This will give me 122. I have 122 plus, we all know this, that is 24 times 2. This is 2 times 4 is 8. And 2 times 2 is what? 4. So I have 48 root 5. Good. Now, we're not done. 61 times 61. 61 times 61, right? You bring it out. 61. Very simple. 1 times 1 is 1. 1 times 6 is 6. 6 times 6 is what? 36. 1 times 1 is 1. 1 times 6 is 6. 6 times 1 is what? 6. And 6 times 6 is what? 36, right? I jumped you. 1 times 1, 1. 1 times 6, 6. 6 times 1, 6. 6 times 6, 36. Good. So you now bring it here. 1, 6 plus 6 is what? 6 plus 6 is 12. Bring that one that you carry to this place. This is 7. And this is what? 3. You have 3,721. So you bring it here. 3,721. Good. Then 61 times 24, because we said that when numbers are multiplying with sword, you finish with a number. So you bring it here. Look at it. Don't assume anything. And don't run to calculator. So we'll do it together. 61 times 24. 4 times 1 is 4. 4 times 6 is 6 plus 6 is 12. 12 plus 12 is 24. That is 4 times 6 is 24. 2 times 1 is 2. 2 times 6 is 12. So this is 4. 4 plus 2 is 8. Is 6. I thought it's 4 times 2. 6. 2 times 2 is 4. And the one, not 2 times 2 is 2 plus 2. Don't mind me. 4 here, since there's nothing under, you bring it down. 4 plus 2 is 6. 2 plus 2 is 4. Then the 1, you bring the 1 there. So I have 1,464. So you now said plus 1,464 root 5. Right? Now, no need of me. There's something I've seen here. We're done with this. We're done with 61 multiplied with the whole of this. Now we're now going to minus 24 root 5 multiplied by 61 plus 24 root 5. Now, minus 24 times 61, I've done it already. Forget that it's minus. It's still the same thing because it's multiplication. Minus 24 times 61 will give me minus this young lady, 1,464, the same what? Root 5. Because there's root 5 outside here. Then now look at it here. And that thing is here. Remember, there's something I told you. I don't know whether you have forgotten. I said, when two things are multiplying like this, look at it. Let me bring it out for you to see. Minus 24 root 5 multiplied by this one is plus, but it will affect this thing and change to what? The same thing. So multiply by minus 24. We have minus 24 multiplied by this. So there are 2 root 5. Right? Now, you look at it, minus 24 root 5 multiplied by this will give me minus 1464 root 5. Then minus 24 root 5 multiplied by plus 24 root 5. So this is what? Minus 24 root 5 multiplied by what? Plus 24 root 5. Now, the first thing you do, you bring these two. Minus 24 times 24, since it's multiplication. Then you bring this one at the front, root 5 times what? Root 5. And I told you that root 5 times root 5 is what? 5. Because if I have root A multiplied by root A is equal to A. Root 1 million multiplied by root 1 million is equal to 1 million. Since it's root. Now, we're done. We're done with what? With that. So what am I supposed to have? I know you know the answer. This minus will affect this. Everything will change to minus there. That means 24 times 24 times 24. 4 times 4 is 16. We all know that. 4 times 2 is 8. But since it's 8, remember, we'll carry 1 from here. So this one will be 9. 2 times 4 is 8. 2 times 4 is 8. And 2 times 2 is what? 4. So we have 6 here. Since there's nothing on that, you bring it down. 9 plus 8. 9 plus 8 is what? 17. Because you carry 1 from 8. 8 becomes 7. And this becomes 10. 17. Then this one is 4. Bring the 1 and plus 1, the one you carry from here. This will become what? 5. So I now have minus 5, 7, 6. Good. Minus 5, 7, 6. Because minus 24 root 5 multiplied by plus 24 root 5, the minus will affect it. It will change to minus 5, 7, 6. Then, now that you have found that very one, what to do is very simple. Remember, there's 5 here. You just finished 24 multiplied by 24. So this will be what? Multiplied by 5. But we can just write the whole thing out so that we'll not go to another line again. Let us do all of them once and for all. We have gotten minus 576 multiplied by 5. 576 multiplied by what? 5. Or there's no need of us going from another line. So 5 times 6 is what? 30. 0, carry 3. 5 times 7 is 35. Now 35 plus 3 will give me 38. Write the 8, carry 3. 5 times 5 is 25. 25 plus 3 is 28. So you have 2,880. 2,880. Now look at it here. Do you know why we did it? That is this multiplied by this. Minus 24 root 5 multiplied by plus 24 root 5. We say that if the two numbers are multiplying with surd of the same value or with root of the same value, you first multiply the numbers, which is 24 multiplied by 24. Then the root 5 multiplied by root 5. And we say root 5 times root 5 is 5. So having multiplied the number, we got 576. Then you have to multiply the root, which gives us what? 2,888. It's like this. Minus 24 times 24 multiplied by root 5 times root 5. So this gives us minus 576 multiplied by root 5 times root 5 is 5 multiplied by root 5, which will give us minus 2880. And that is what we got here. So I believe that I've done justice to this, right? Good. Good. Now, since we have done that, I want you to look at something. 1464 root 5 minus 1464 root 5 will take care of each other. Look at it here. This goes with this because they are the same. So I'm going to have 2 minus 2. So it's 0. But in this place, we cannot write 0. It's just clear it. Then this one is 3721 minus 288 what? 0. So what you are having left from there will now be in this form. 122 plus 48 root 5 over, look at it, you have 3721 minus 2880. Yes, and we have 3721, then 880, you put it in this way, minus 1 minus 0 is 1. This one 2 cannot take from here. This becomes 12. 12 minus 8 is 4. this becomes what? 6. So you carry 1 from here, this becomes 16. And remember, this becomes 2. So 16 from 8 is 8. And 2 minus 2 is 0. So you have this. Good. So what you have here will now be what? 122 plus 4 8 root 5 over 841. 841. So for you to write it out, what you have will now be what? 122 over 841 plus 4 8 root 5 over 841. So now this is now in the form of A, B, and C in this form. So if you want to write it according to WAEC, you can easily bring this one here. Let me write it for you. 841. Then they'll now put at the front like this. Root 5. This is the C. This is the C. In form of A, they say leave your answer in the form of A, B, and C. So this becomes what? A, B, and C. The C is the surd. Is the irrational in form of what? Irrational number in form of surd, in form of root, which is the surd. Give us this. So what is there is that we have gotten this. The other one that is there is the E. So I want you to look at this very well. Remember what I did throughout. I don't use calculator. I did not use calculator. Now what we did from that place, we said that we need to what? Rationalize. And to rationalize is to find the opposite of this by the sign. And what you do to the denominator, you do the same thing to the what? Numerator. To avoid what? Impartiality. It must be partial in mathematics. So we did the same thing to the numerator by adding the conjugate to this and this, rationalizing. Now, we now came here, we open it the same way we have been opening it. I said you open your bracket, which you did. Then we said that the only what we want to achieve when they say rationalize is for us to remove the root from the denominator. I told you from the beginning, and when we came here, the roots took care of each other. So we're now left with number, and we express our answer in the form of A, B, and C, where A is direct rational numbers, which we say that it can be expressed in fraction. C is an attachment to the irrational number in form of root, which is the surd, and we'll have it here. Then the C is the root 5. So this has been what? Done. You can just what? Mark 8. Good. So I want you to look at it very well, because I will clean it and do justice to the E. I'll do justice to E, then justice to F. I'll do justice to F. I'll do justice to F. So remaining 2, what to do is to what? Is to take care of this. If I finish everything, I must write them out. Good. So the E, I want to explain something there. I want to explain something there. So we're given 4 root 1 over 32 minus 2 root 1 over 8. We're given this. So you write equal to, since you have written solution before, you know, we started from A, B, C, D, E, then remaining F. Now what we have to do here is what? 32. You know, there's something I want to do. So this will give me 4, be watching, 1/16 multiplied by 2 minus 2 1/4 multiplied by 2. I told us from the beginning, I said in simplification, or sorry, in simplifying this kind of question, what you need to do is very simple. You look at the number given to you. Is there any one that if you can separate to find the root directly? Just like when we have 162. I found out that 81 times 2 will give me 162. And 81, I can find the root. So this very one, when I'm seeing 32, another 16 times 2 will give me 32. And I can find the square root of 16. So this becomes what? According to the rule, I have 4. Remember, I can have 1 over what? 16 multiplied by 2. Yes. Because it's in the rule. We said that if you have A over B, the same thing as what? Root A over what? Root B. We said it. So that's what I applied here. Since the root is for both of them, I gave it to 1 and I gave it to 16 multiplied by 2. So minus 2, the same thing will happen here. I'll give 1 its own root, that is the respect, and I'll give this one to their own root. Good. So having done this, I can say that this is the same thing as what? 4 root 1 over root 16 multiplied by root 2. Yes. Minus 2 root 1 over root 4 multiplied by root 2. Yes, because they said if you have something like this, root A multiplied by B, the same thing as root A multiplied by what? Root B. So that is what I did. I separated them again with their roots. So this will now give me what? 4. You know, root 1 is 1. Nth root of 1 is 1. Root 1 is 1. So I now have 4, 1 over root 16 is 4. 16 is 4. Root 2 minus 2, root 1 is 1. Root 4 is 2. Root 2. You understand? You know, when something is like this, they multiply up. So this will now give me 4 over 4 root 2 minus 2 over 2 root 2. Remember, 4 is here, 4 is here. They can take care of each other. 2 is here, 2 is here. They can take care of each other. I'll now have what? 1 over root 2 minus 1 over what? Root 2. A minus A is 0. 2 minus 2 is 0. So I have 1 over root 2 minus 1 over root 2. What do you expect is 0. So I now have equal to what? 0. And you have done justice to this. So look at it very well. I'll be jumping some steps in the last one because I know that you have understood what? Surd. So this is what I did. The E, I was able to do justice to the E by using the rules of surd. By using the what? The rules of surd. I just follow the rules. Follow the rule down. Remember, modern technology will be unthinkable without mathematics. So now we're done with this. Let me go to F, where I was stopped. F where I will what? Stop. I'll stop at F where I will what? Stop. Good. Now, having reached this place, I can say, sorry, my marker, I can say that this is like this. Let me separate so that I can solve without cleaning the board. Good. The board. Now, we're given to simplify 1 over 9 raised to the power of 1 over 9. I've done 1 over 6 raised to the power of 1 over 6, if I'm not mistaken. You can go to that place to know the steps. But I want to explain this because you have known sword. Let me explain that. You know, if you have something like this, we can say that it's the same thing as what? Like this, right? Or, since I don't want to put it fully, let me give you the whole board so that I can be able to explain well, right? We're given like this. Now, what do we do? It's as simple as ABC. We say that it's like this, 1 over 9. The down one will serve as the root, or raised to the power of what? 1. Do you know why? We say that if you have a raised to the power of m over n, it will give me the what? The nth root of a raised to the power of what? M. That is what I did here. I know anything raised to the power of 1 is that the same thing. So I now have what? The 9th root of 1 over 9. Because anything raised to the power of 1 gives what? 1. If I have a raised to the power of 1, the same thing as what? A. Right, that's what I did here. This one has gone. Now, look at what I'll do again. Remember our following sort that we have learned. So this will now give me the 9th root of 1, the 9th root of 1 over the 9th root of 9. Right? Because we said the 9th root of what? 9. Right? Because we said that if you have anything like this, if I have anything like this, maybe the nth root of a over of m over, or let's say a over b, since I'm using n here, it will give me the nth root of a over the nth root of b. Good. So that is what I did from here, right? Before I reach here. So since the nth root of a over b will give me the nth root of a over the nth root of b, I'm correct. It's a surdic. It's one of the rules of surd. Good. Now what will I do from here? You all know that what I'll do from here is what? 1 over the 9th root of 9. Yes, 1 over the 9th root of 9. Because we said that the nth root of 1 is what? 1. So if I have the nth root of 1 to be 1, it simply means that the 9th root of 1 is 1. Then left with this. Yes. So from here, you can do justice to it, but I will not let that be for now. What I'll do again is to what? Bring it like this. Look at what I'm going to do here. I have 1 over the 9th root of 9, right? Now there's something that used to happen if you have something like that. Now let me tell you that 1 over the nth root of A will be equal to what? 1 over the nth root of A dot nth root of A n minus 1 over the nth root of A n minus 1. So that's what I want to do here. If I have something like this, 1 over the nth root of A, which is the same as 1 over the 9th root of 9. You know that this one's alphabet. So what I'll have is 1 over the nth root of A multiplied by the nth root of A raised to the power of n minus 1 over the nth root of A raised to the power of n minus 1. So here I'm going to have what? It will now give me, since I have something like this, so it will now give me dot, because I'm working on this now to get this. Now give me dot the 9th root of 9 minus 1 of 9 minus 1, because it's the root, I'm using the same root, over the 9th root, bring the same number in, the root is 9, I'll bring the 9 here, minus 1. So that's what I did there. So this will now give me what? 1 over the 9th root of 9 dot, this will give me the 9th root of 9 raised to the power of 8 over the 9th root of 9 raised to the power of what? 8. That is 9 minus 1, 9 minus 1. Now, if you have the same thing, now we're having 9 here, 9 here, and they are multiplying each other. So we bring them together. Remember that this one is raised to the power of 1. Anything on its own is raised to the power of 1. So what I'll have here is what? 1 over the 9th root of 9 raised to the power of 1 dot the 9th root of 9 raised to the power of 8 over the 9th root of 9 raised to the power of 8. I have 1 here because, say it here, A is the same thing as A raised to the power of 1. So if I have any number, I can put raised to the power of 1. So look at it very well so that I'll continue from here. Very short. I started from here. I define this. Come to this line. I say 1 has gone because anything raised to the power of 1 is at the same thing. Then I came to this place. I defined this according to the sword, that the nth root of A over B is the same thing as the nth root of A over the nth root of what? B. That's why I shared this for them. Then I came to this very line. Nth root of 1 is 1, and the square root of 1 is 1. So the 9th root of 1 is 1. Then I brought the same thing down. And whenever I have something like this, what I'll have is that the 1 over the nth root of A dot nth root raised to the power of 1, right? So that is that about that. Good. Good. So what we have down is what? Can continue from there. So once you have something like that, it will now give us what? 1 over the ninth root of 9 raised to the power of 1 dot the ninth root of 9 raised to the power of 9 raised to the power of 8 over the ninth root of 9 to the power of 8. That is what I was explaining down there. So I brought it up and I said that what we have, that is a is the same thing as a raised to the power of what? 1. Before we're not having 9 raised to the power of 1, which I added. So now that it's like this, see what we have. This is the same thing as 1. This multiplied by this will give me 1 multiplied by the ninth root of 9 raised to the power of 8 is the same thing as the ninth root of 9 raised to the power of 8. So I now have the ninth root of 9 raised to the power of 8 over this, the same thing as what? The ninth root of 9 raised to the power of 1 dot 9 raised to the power of 8. Yes, because we say that the two surds can multiply each other. So this will now give me what? The ninth root of 9 raised to the power of 8 over the ninth root of 9 raised to the power of 1 plus 8, right? Because you know that if I have a raised to the power of m multiplied by a raised to the power of n is the same thing as a raised to the power of m plus n, right? So that is what I did here, 1 plus 8. Good. So this will now give me what? The ninth root of 9 raised to the power of 8 over the ninth root of 9 raised to the power of 9. Because 9 plus 9, 1 plus 8 is 9. So, and this will now give me what? The ninth root of 9 raised to the power of 8 over 9. Because if I have the nth root of a raised to the power of n is a. The nth root of a raised to the power of n is a, because this n will take care of the n inside. And if you look at it, 9 is here, 9 is still the power. So 9 take care of the ninth root, remain 9. So what we have is the ninth root of 9 raised to the power of 8 over 9. Right? Now, if we have something like this, we can still proceed further. But now that it's like this, I want you to do it because you have to take this. Let me just run on it. So this will give me the ninth root of 9 of 3 raised to the power of 2 raised to the power of 8 over 9. What I did here is that 9 is the same thing as 3 raised to the power of 2. So don't be confused. That is the 9 inside, and this is the 8. So from here, I can still have the ninth root of 3 raised to the power of 16 over 9. Right? Let me write it out here. The ninth root of 3 raised to the power of 16 over 9. That is equal to this. Remember, why I put it like this is, we all know that a raised to the power of m raised to the power of n, the same thing as a raised to the power of mn. That is what's happened there. So this one, 8 times 2 is 16. Then the 9 is there. I'll be fast. I'm done with this. Right? So what will you do again? Remember, what we're having from there is the ninth root of this over this. So this is what we have from the down. The ninth root of 3 raised to the power of 16 over 9. And if you look at this very well, we can have something like this. This one will give me 16 over 9. If I want to remove the roots here, this root will go inside. But from here, I believe that you can do justice to 8 very well. It will be very simple. Our major aim is to take this from the denominator. To take this. So if you take it from the denominator, we are now happy that the denominator will not have anything like the sword. Because I know that you will be tired. But what you're supposed to do from here is 3 raised to the power of 16 over 9. Then all over 9. So you simplify it and get this. That is part of your assignment because I have done this. But if you not do it, if you not finish it, you look at the comment section. From here, just a little thing I want you to do. But if you have not finished it, then you look at the comment section where I will just drop it. Like 3 lines from here. I want you to think what you do here. Like 3 lines from here, you get it. So what I want you to do for me, apart from this, is to do this. Evaluate and rationalize. 5 minus 2 root 10 minus 2 times root 10 over 3 times root 5 plus root 2. Do justice to it and I'll be very glad. So thank you so much for watching today's lesson. And don't forget, if you like it, to follow me on our Facebook page, Mathematics and Technology Skills. And if you are watching this on YouTube, please don't forget to subscribe to my channel at Matex12, the Celebrity Mathematician. And again, comment and share so that others can learn. If you notice another thing again that I am supposed to do, kindly let me know. Thank you so much for watching. I am Omale Jeffrey Jojo, your Celebrity Mathematician.